Here we are at 9.4, solving quadratic equations using the quadratic formula. Today's learning goal is I will solve the quadratic equation using the quadratic formula. And also, I will use discriminants to determine the number of real solutions. Of quadratic equations. So this is a long one. This section is probably the most straightforward. Although, well, maybe not. 9.2 is pretty easy, but the only problem with this section is you do have to learn a formula, and it can be a little bit tricky. So my first piece of advice to you is to write this formula down 1,000,000 times. Write it down, write it down, write it down, write it down, so you have it totally memorized. Every single time you do a problem using it, I would write the formula down using the letters first, using the A, B, and C first, and then plug in what you know, because that's really the only way you're going to remember this. So here it is, the quadratic formula. Ask your parents, they might still remember it. This is the kind of thing that sticks in your head forever and ever and ever once you've done it once. So the quadratic formula, x equals negative b plus or minus square root b squared minus 4ac all over 2a. That is your quadratic formula, and that's what you are going to use to solve these quadratic equations. So this is just what you need to know. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. You just need to know that. So let's see what this means. Let's say you were given an equation, or quadratic equation, that looked like this. Now, I guess I'm getting ahead of myself. You're going to use this quadratic formula when you have an equation that looks like this. So whenever you have a quadratic that's equal to 0, you can use a quadratic formula to solve for x. So if this was equal to 17, I wouldn't be able to use this formula. I would need to adjust it so we're equal to 0. So just keep that in mind. So here's what I have. Here's my equation. Remember, this is A, this is B, and this is C, and this is the equation I'm going to use, or the formula I'm going to use. Negative b plus or minus square root b squared minus 4ac all over 2a. Write that down first. That should be your first step. Then I'm going to plug in what I have. So negative 7 plus or minus square root 7 squared minus 4 times 2 times 3. That's all under the square root. And all of that then is divided by 2 times 2. So then I just plugged in my information. And from here I just solve. But there's a lot going on here, and people tend to make mistakes even though it's not difficult. It's just a lot of different computations. So what I would do first, do what's under the square root, and then do the 7 plus that, 7 minus that. So what we're going to do is I'm going to leave the 7 plus or minus square root. 7 squared is 49. 4 times 2 is 8, times 3 is 24. And all of that is over 2 times 2, which is 4. And then from here, this is going to be, oh, I forgot my negative sign. See? All sorts of places you can make mistakes. Then I put a negative 7 plus or minus the square root of 49 minus 24 is 25. And that's all going to be over 4. And then from here, it's negative 7 plus or minus square root of 25 is 5, all over 4. So that's either negative 7 plus 5 over 4 or negative 7 minus 5 over 4. Those are my two possible solutions for x. Negative 7 plus 5 is negative 2 over 4. Negative 7 minus 5 is negative 12 over 4. So that's negative, either negative 1/2 or that's going to be negative 3. So my final solution using the quadratic formula is x equals negative 3 or negative 1/2. And I could plug both of those back into my original equation. I could put in negative 3, so this would be 2 times 9, which is 18, minus 21 is negative 3, plus 3 is 0. I could do the same thing with negative 1/2, and I should still get 0. So, like I said, this isn't difficult. You just have to be careful, especially like you saw how I forgot that negative sign there. Or when you put this into your calculator, if b is negative, you want to be really careful when you're squaring it. There's just all sorts of places for you to make mistakes. So if you just go through it step by step, like these problems, I mean, obviously I took up a little bit more room than I needed to, but these problems should take up quite a bit of space because you really just need to do the computations step by step. So that's what we're looking at. This is how you use the quadratic formula. Okay, so our next problem, let's do another one. 4x squared plus 20x plus 25 equals 0. And I want you to solve that using the quadratic formula. So x equals negative b plus or minus square root b squared minus 4ac all over 2a. And if you're curious as to where that came from, how that was developed, just look in the activity that goes with this section. It goes through all the algebra behind it. It's kind of interesting to look at just to see how they came up with such a totally random equation for solving. So a is 4, b is 20, c is 25. So x equals negative 20 plus or minus square root 20 squared minus 4 times 4 times 25 all over 2 times 4. So this will be negative 20 plus or minus square root 400 minus 4 times 4 is 16 times 25 is 400 all over 8. So I get 20 plus or minus the square root of 0 over 8. Square root of 0 is just 0. We don't need to add or subtract 0. So we're going to end up with just 20 over 8, which simplifies to, oh, what did I forget? My negative sign. See, I'm just showing you where you can make mistakes. I knew that was missing, right? So 20 over 8, 4 goes into 8 twice, 4 goes into 20 5 times, and it's negative. So here I only have one solution, and it's negative 5/2. So in this case, if you look at what ended up under that square root, we ended up with a 0. So we didn't have a plus or a minus here. It was just 0. Previously, we had a 5 under there, so we could either add 5 or we could subtract 5. We had two different directions we could go, so we had two solutions. So hopefully this is kind of ringing a bell with what we did before. You know, we had two solutions, we had one solution, we also had no solutions. So let's see if we have this one. Oops, sorry, let's try this. X squared plus 2x plus 5 equals 0. And I want to use the quadratic formula. negative b plus or minus square root b squared minus 4ac all over 2a. Let's plug in a, b, and c. So negative 2 plus or minus square root 2 squared minus 4 times, 1. Remember our coefficient on that x squared is 1. 4 times 1 times 5. All over 2 times 1. Simplify a little bit further. Negative 2 plus or minus square root of 4 minus, that's 4 times 5, which is 20, all over 2. And then we have negative 2 plus or minus square root of negative 16 all over 2. And right here, you see that we have a negative under a square root, not possible. So we stop right there and we can say there are no real solutions to this quadratic. So if this were a graph, it would look something like that, where it never crosses the x-axis. So here we had that negative, and that's why we had no real solutions, because there was a negative under the square root. And that brings us into the next part of this section. So in all of those examples that we did, what was under the square root is what determined if we had 2 solutions, 1 solution, or no solutions. So we call just this part the b squared minus 4ac. That's a really important thing here, and we call it the discriminant. So if you are asked to find the discriminant, it's just asking for you to find what b squared minus 4ac is. And the reason we call it the discriminant is because it helps us to decide if we're going to have 2 solutions, 1 solution, or no solutions. So a lot of times what you can do, you can find that discriminant first. Like if I had found the discriminant first in our previous example, I would have known there were no real solutions, and that would have saved me a little bit of extra work. Then if it turns out that there are more solutions, or that there are 2 solutions or 1 solution, I've already figured out what goes under that square root, so I've already done a step toward solving the problem. So for these, you actually might just be given a problem that looks like this, where it says determine the number of solutions, or the number of real solutions, because right now we're only dealing with real numbers, of, how about 4x squared, this looks just like the one we just did. Let's do a different one. X squared plus 8x minus 3 equals 0. So determine the number of real solutions. When you're just asked how many solutions there are, all you have to do is use the discriminant. You don't have to tell what the solutions are, just how many. So we only need the b squared minus 4ac part. So in this case, a is 1, b is 8, c is negative 3. Be really careful, you're subtracting 3. So think about that as adding a negative 3 there when you plug into this portion of the quadratic formula. So 8 squared minus 4 times 1 times negative 3. So this will be 64 minus 4 times 1 is 4 times negative 3 is negative 12. So then this will be 64 plus 12, and that gives us 76. That means that when we have our quadratic formula, negative b plus or minus square root all over 2a, under here we're going to have a positive 76. That means we'll be able to add whatever that square root is, and we'll be able to subtract it. So there are 2 real solutions. So if this right here, if this discriminant is greater than 0, we have 2 real solutions. If we do all of that work and we get 0 under there, so like in this situation, see, we have x squared plus 2. Nope, we already did that one. Oh my, I just want to find one for us to do. Oh, negative x squared plus 4x minus 4 equals 0. If this were the situation, again, use the discriminant, b squared minus 4ac. b is 4, a is negative 1, c is negative 4. So we get 16 minus, that's negative 4 times negative 4 is negative 6, no, sorry, positive 16. 16 minus 16 is 0. So that means we're taking the square root of 0, so we don't have anything to add or subtract there. So we have one solution in this situation. And then just like the problem that we did, where was it, on this page, here we ended up with a negative for the discriminant, and then we had no real solutions. So if you do the discriminant part first, then you at least know how many solutions you're going to wind up with. So look through your book, look at the examples in the book, and they have a nice like picture that shows what they're talking about. But this is really pretty straightforward. So the hardest part is just remembering this formula. Like I said, just do it over and over and over and over and over until you know it in your sleep. You should be dreaming about the quadratic formula. Okay, our final problem is a word problem. This is a really good example of why we want the quadratic formula. The number y of Northern Rocky Mountain wolf breeding pairs X years since 1995 can be modeled by y equals 34/100 x squared plus 3x plus 9. We want to know when were there 55 breeding pairs. So y represents how many pairs there are, x represents how many years since 1995. So like 1996, x would be 1. 2000, x would be 15, just to give us that idea. So the big thing here is that these numbers are ugly, and it would be really, really hard, if not impossible, for us to factor these or to try and complete the square or graph or do any of that other crazy stuff we've been doing. So this is exactly why we have the quadratic formula. So what we have here, we want to know when were there 55 pairs. So y is 55. And when I do this, we have a small problem. Look, we're not equal to 0. So the first thing we have to do is subtract 55 from each side, so we get 0. 0 equals 0.34x squared plus, I'm going to write that as 3x just to save myself a little ink. And then 9 minus 55 is going to be negative 46, or I'm going to be subtracting 46. So this is my setup for my quadratic. Here's A, here's B, here's C. Don't forget that negative when you do C. So negative b plus or minus square root, sorry, that's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So negative 3 plus or minus square root 3 squared minus 4 times 0.34 times negative 46. I'm going to draw that all the way out. All over 2 times 0.34. And here's where I'm probably going to want to get my calculator out, because I'll have negative 3 plus or minus square root of 9 minus, let's see, what is 4 times 34/100 times negative 46. So negative 62.56. I'm subtracting a negative 62.56, so that's actually going to be added, and that's all over 68/100. So let's do 9 plus 62.56 and take the square root of that. So this becomes negative 3 plus or minus 8.4, let's see, 0.46 all over 0.68. Sorry, I ran off the page there. Okay, right now I can see if I do -3 minus 8.46, I'm going to get a negative number. And that's not going to make any sense in relation to this situation up here. So I can just cross that negative sign out. It doesn't make any sense here. But what I can do then is I can do -3 plus, and I'm going to do second answer, and it just pulls up that number, that 8.459 whatever. I'm going to then, so that's this top part of my equation is 5.46. Then I'm going to divide by 0.68, and I get 8.02. So what that says is approximately 8 years after 1995, there are 55 breeding pairs. So 1995 plus 8 is going to give me 2003. So in 2003, there were approximately 55 breeding pairs. So hopefully you were just able to follow that. It was really just plugging in the numbers. But you saw that even when I used my calculator, I did what was under the square root first, and then I would have done the plus or minus, but in this case we didn't have to subtract. And then we keep going from there. So let me give you your homework assignment. And of course, if you're a little bit stuck, you can always get some extra help, either from a mentor or from me or the sub or whoever's around. But hopefully once you get this formula memorized, it won't be a big deal. So this is page 481. You're going to do numbers, oh, Josie, stop. Numbers 1, 2, 16 through 22 even, 31 through 35. This looks like a lot of problems, but a couple of them are just using the discriminant where it just says determine how many solutions there are. Those ones don't take a whole lot of work. So here's your whole assignment. Good luck.